Hello, today we're going to talk about the TH1000. We're going to talk about all the parts that go into the assembly process. That way you can easily service, maintain, keep your TH1000 working great. There's some fine tuning that you may need to do over time, so what we want to do is educate you on this process of putting it back together. We've already disassembled it. We have all the parts laid out here. We want to talk about each part briefly, and then we'll talk about the assembly process. So if you have to do any type of service or repair, we can kind of talk you through that process. So it's kind of a dry video here. We'll hopefully keep you in tune, but we'll talk about all the parts and go from there. So first off, what I want to do is talk about the aluminum extrusion. It's a three-piece assembly. As you can see, I took off the measuring device here. It's laying flat in front of me. So what you have here is a strike bar. You have two L-shaped brackets that actually hold the indicators in place. And then you have the slide mechanisms. Now, I took out the detents that go into these three holes here. There's three of them. That's what prevents the assembly from just retracting or extending out. So in this case, I've removed them, so you'll see it's free sliding. So if you ever have a problem, just take those out and see if the assemblies slide up and down nice and easily. As you can see, it's a three-piece one, so very smooth sliding, which is what you want. Maybe over time, after thousands of cycles, the plastic caps that it slides on may wear out over time and you may need a new one. It's not serviceable at that point. But this assembly is robust. It should last for a long, long, long time. Alright? So as you can see, it slides really easily. Just by gravity, it's going to extend. Alright. So the detents are what's key to this. So before we get into the detents, I do want to talk about the mounting bolts. So we have two mounting bolts in the back. They are held in place with a square notch that's in the aluminum, and then the special type of flathead bolt with a square base to it, and then the threaded shaft comes out here and we have it held in place with a nut. So we want to make sure that these mounting bolts never come loose, because if they come loose they will impact the slide. And I'll show you the back side of this here in a second. But so what we want to do is put Loctite on the threads here and tighten down the nut. So we'll do that here in a second as well. So let me show you the other side of those mounting bolts. So the inner slide is out, so we'll talk about this one here. So it's a flat bolt, and the plastic has a recess and a notch in it to allow it to pass through the top of the stove bolt, I'll call it. So typically what those type of flathead bolts are called are stove bolts. And so what happens here is the slide can slide right past it. It's pretty tight tolerances in here, but the height of the head, there's enough clearance that it can slide right by the head of the bolt. Now if that bolt comes loose, this nut comes loose, you won't be able to extend. It'll hit on the top of the head of the bolt. So if yours isn't extending well, let's make sure those mounting bolts are still tight. For whatever reason, that nut did not come loose, so we want to make sure that it always remains tight and held in place. Alright, so that's the mounting bolt. So what we're going to do is I'm going to go ahead and show you how to make sure you put Loctite on properly onto these mounting bolts. Alright, so now let's start the assembly process. In your case, you will have these already permanently locked in place, but we're going to go ahead and do this. This is one of the first batches we received from the manufacturer. We didn't make this change till after some additional hours in the field where customers were putting a lot of cycles on it, and we know some of the nuts may be coming slightly loose. So we want to go ahead and apply a few drops of red Loctite to the threads of the mounting bolts near the washer. We'll put a couple drops here, a couple drops here. We got the paper towels underneath just in case it leaks around. We don't want to make a mess on the table. We tighten that back up. So what I do is I pull the bowl out toward you, so we lock the square notches in place. Then we go ahead and run the nut down tight. And then we'll go ahead and do this same thing on this side. Simple. And then we'll go and take the 14 millimeter. We don't have a particular torque on this. It's just really good and tight. All right. We don't want those to come loose. All right. And it's a large bolt, so the likelihood of you snapping this off if you ever have to do it is pretty slim. Alright, so we got those nice and tight now. Alright, so now we'll move on to the second part of the assembly process, is putting the detents in. As you can see, it slides up and down really easily. We want to now put the detents in here. I'll go ahead and remove the paper towels. We'll make sure there is no drips or cleanups on these at all. Alright, we're perfectly clean. We'll set those aside. Alright, so now we're going to get into the Teflon tape, and we will get into the 3 detents. So, detents. There's 2 sizes. There's 2 of the small ones and 1 of the longer one. It is a spring-loaded ball on the end of a threaded shaft that you can loosen and tighten with an Allen wrench on the other end. On the inside is a spring. So as you tighten it down, it takes more force to push the ball back in against that spring. So when you are tightening this, you're making it harder to pull the assembly down and harder to push it back up. So if you want it to be easier to pull down and push back up, you turn this counterclockwise, so you loosen it. And what it does is that the ball actually comes out of the back. You'll see on here, there's 2 holes. So the ball actually goes into the hole. So what you're doing is pulling the ball out of the hole and making it easier to pull the assembly down and push it back up. So these are called detents. It's a spring-loaded ball. It's really a genius part of the invention. This is what keeps the measuring device at the elevated position, so we can have it at a resting position 10, 11 feet in the air, pull it down when you're ready to use it. Instead of having it chest height where all the adjustments are done at chest height, which that means people can walk by and abuse the equipment when it's not in use. In our case, when the equipment's not in use, it's 10, 11 feet in the air, you're not going to be able to abuse it, right? So these spring-loaded balls hold it in place until you apply a force to release it. So these are really key to the overall operation of the equipment. So if it is sliding down too easily, you need to use the Allen wrench and tighten them. If it is too hard to pull down, you need to use the Allen wrench and loosen them. It's that simple. So what we're going to do is go ahead and put Teflon tape around the threads here. And there's a couple of different ways to do it, but what I like to do is do it 2 passes. So what I'll do is I'll make sure I put the Teflon tape the right way. We don't want it, as you tighten it back into the assembly, you don't want the Teflon tape to peel back off. So you have to make sure that you put it on the way you need to make sure when you tightening it up, it doesn't unpeel away from the thread. So what I like to do is do 2 passes. So I'll use one a couple times around, and the first pass is getting into the V of the thread really tight. So I'll go ahead and run this in and then back it back out, and then put a second layer on it to make sure it's nice and tight. So this first pass, I kind of can get a feel for how much Teflon tape I need to put on the second time, because each one's going to be a little bit different. It's just machining tolerances on both parts. So run this down, and this first time I'm doing it, it's already pretty tight, so I only will need a couple layers of it when I take it back off. So I run it all the way kind of down, and what happens there is it pushes that Teflon tape deep into the threads. So you can see now the threads will actually poke through some of the Teflon tape, and you can tell the colors change in the blue. It turns darker blue as it gets compressed, so it kind of helps you gauge how to do it. So I'll do one more layer of Teflon tape. I like to use the whiter stuff for the big one, and you most likely will never have to do this because it'll come to you with this Teflon tape on there. But if you ever have the need to tighten it up because you really used it an awful lot and you need to do that, this is how you do it. Just put a couple layers of Teflon tape on there, run it down all the way tight. So I run it all the way down tight to where the ball pushes through the hole, and then I back it off 1 full turn. So 360-degree counterclockwise turn. And that's about the right amount of force for the assembly. Now you may want it looser, you may want it tighter. It's entirely up to you in the application. So for a wall mount, with this, if this attaches to a wall mount, usually you want it a little bit looser because the wall mount isn't as rigid, I'll say, as a floor stand. A floor stand, you can hold the floor stand and really have it to where it's tight as you move it up and down. In that application, usually it's better to have it a little stiffer, a little harder to pull it up and down. With a wall mount, you may want it a little bit looser, or a basketball rim mount, you may want it a little looser to make it a little easier to pull out or release. Alright, so I'll show you what happens here. So I did that one. So this is my inner one. So what's happening now is the exterior one is sliding, so I'm going to try to hold that in place. But we got this to where this one is the one sliding, and it's pretty loose right now, which is pretty good. So what we'll do now, go ahead and put the top two in there as well, and same process, 2 pass on the Teflon tape. That seems to work really well. You don't want to get too much of it around the ball itself. You don't want to get Teflon tape inside where the spring's at. So keep it away from the end of the shaft. And we'll put a couple coats on there. Thread it into the hole and do it same thing. So we'll kind of fast forward the video here so you don't have to watch this whole process, and then complete this step and show you what it looks like. Alright, so now we got the D10 in there. So now you'll see how this one comes out pretty easily. Alright, so we don't like that. We want a little bit tighter. So all I do is tighten this up. Do a little quarter turn. Now we'll put it back up. That part won't come out. Apply a little bit more force, and now it comes out. And then if you have the adjustment right on the other one, which we'll fine tune once we put everything together, it has more weight and depending on the application. So this one's still pretty tight. You can tell I can't release the top one yet, even with a little force. So now what I'll do is I'll go ahead and loosen that, because we'll go ahead and get it somewhat close out of the gate. So probably there, a little bit more of a quarter turn on both of them. And that should do us on those as well. So that's your first one. And then this is your second one. So they're pretty close right now. You can you see it's still a little tight, so let's go ahead. I'm going to show you if I loosen it up how smooth it'll slide. It's a little hard doing it from a standing position and not on a mount, but I like to show you the sliding mechanisms. Alright, so now that's a lot easier. Alright, so that's the first one, and that's the second one. Alright, so that's pretty good. Alright, so that is the part of the system that extends and retracts and holds the measuring device in place. So as you can see, it's pretty simple. You have your strike bar, a couple bolts there. That's never going to get damaged. You have your aluminum extrusions. You're not going to damage those. You have your D10s. This is the only adjustment you should have to make during use. So get familiar with those. It's pretty straightforward. It's just an Allen wrench, tighten and loosen. It allows you to extend and retract it with a little less or more force. Okay, you can tailor it to your liking and your application. Alright, so we'll set this aside, and I want to show you the measuring device part of it, which is the plastic indicators. Okay, so I'm going to go ahead and set this aside. I'm going to pull out this one. So this is our bottom one we had here. So this is an indicator. It's plastic, injection molded. we have put a lot of engineering time into this to make sure that don't break. You can beat these things, you can twist them, you can hit them. These things are robust. They're going to hold their shape. They're 1 inch spacing between each one. We alternate the colors to make it easier to see. We have screen printed numbers on the bottom of it. All the math to do vertical jump is right here. Okay, so let me go ahead and educate you a little bit on this, the numbering system. So we have 3 levels, as I show the extensions. At the fully retracted position, at the highest point, we use the largest numbers. So if you hit something, use the largest numbers. Okay? At the middle level, where you semi-retract it or semi-extend it, it's the middle position. Use the middle set of numbers. If you pull it all the way down, you use the smallest set of numbers. Okay? So it's all the way down, you stand up, and you reach, and I'm going to go ahead and grab the second one. Okay? So I got the first one at the very bottom, which is 60 inches from the ground if you use one of our 3 mounts. So it's 60 inches from the ground, fully retracted, all the way down. You stand up and you hit this one, but you're not able to hit the second one, which is 61 inches. Okay, so 61 inches, standing up, you can't quite hit 61. That one doesn't move. You use this number. That is your baseline number, standing reach number. Okay, you will subtract that from whatever you don't hit. Okay, so let me talk about the second number now. Okay, so now you can jump fairly high. So standing up, you can't quite hit 61. So 61 is our standing reach number. Okay, so now you extend it up halfway, and so now you're halfway. So you're going to use the middle set of numbers. So you jump up and you hit. You just barely hit the bottom one, and so you move 89. Okay, so that's the middle set of numbers. So because you didn't hit 90, you take 90 minus the number you didn't hit before, which was 61. So you do the math between 90 and 61, and that is a 29-inch vertical jump. Okay, so 90 minus 61, 29 inch. That's how you measure your vertical jump. It's all done right here on the plastic indicators. You don't have to add up anything from the floor stand or anything else. All the math is done right here on these. 1 inch increments, standing reach, hit a number, and whatever version of a jump you want to do, whatever number you hit, you do the math on that, and that is how you do the math. So anyways, pretty robust. Haven't had any of these break. They're hard. You can beat them. These things don't break. That's what makes this thing so special. It's engineered to last a long time. Alright, so say someone does a chin up. They do a chin up on it and break one. It's going to happen. Or you put it in a gym and someone hits a baseball and the baseball hits it really hard and breaks it. You can replace this really easy. All you do is buy a new one, take this apart like we did, slide it on, and you're back in business. It's that simple. So now what we're going to do is go ahead and assemble this back onto the aluminum extrusions. So what we do is just slide the bar through the 2 holes. So we're going to go ahead and do that now. A little hard for me to do it here facing the camera. So what we do is we put the washers on first. So we have a spring-loaded, kind of a spring washer, and then a regular washer. So we put the regular washer on first, then the spring washer, and then we slide that up into the indicator hole bracket, the hole in the indicator bracket on one side, and then we'll go ahead and temporarily put the nut or the bolt and the washer on one end, just so we don't have that slide back out on us. Okay, so we'll hand tighten that all the way down, just to kind of make sure that it doesn't come back out now. And on the other end, what we're doing is we are sliding this in position. We gotta get the rod a little higher on this side, so it allows us to get this lined up down here. So we slowly push the rod in, and that's sometimes you need your little persuasion tool a little bit. Just give a little bit of a tap. So now we want the rod to come through just a little bit, which we've done. So that allows us to put the washer on first, and then we want to tap it a little bit more. All right, and then now that allows us to come back and put the spring washer on. Okay, so we put the spring washer on, then we line stuff back up, and then we'll put the bolts in. So let me go ahead and do it here so it's a little easier for me at my angle. Sometimes it's even easier standing up and getting that put in there. So all we're doing is lining this up. And we'll go ahead and do the same thing. It's nice to get this started as well. It holds the spring-loaded washer in place and we put the bolt in. We can do it two ways. We can tap the rod through here. The only hard part about this is keeping that little spring washer right in place. And sometimes I like to do a little tap. And if everything lines up well, it'll tap itself right in place, which is what happened here. Alright, so now we get into how do we make sure that these bolts never come loose. As we keep hitting this and vibrations happen, bolts can loosen up. Alright, so what we're going to do now is, as you can see, the rod's holding it in place. We got one bolt in here. We're going to go ahead and take this bolt off as well now. But first we're going to go ahead and I'm going to show you what to do with the Loctite. So blue Loctite is removable. It allows you still to service it. So if you do break one, you can get back in there and replace it. You don't want to put red on there and run the risk of not being able to disassemble the unit. So we're going to use blue. In this application, because we have a threaded rod and we have the bolts, we don't want to put the threaded Loctite on the threads. We actually have to put it in the rod hole, the threaded hole in the rod, because there's essentially an air pocket. As we tighten this in there, the air that will be trapped, because it's called a blind hole, as you tighten it in, the air will push the sealant off the threads and out of the hole. So what you want to do now is put the sealant in the bottom of the hole, so as air pressure builds up, as you tighten the bolt in there, the air has to escape. It won't take all the sealant with it. So then as we tighten it in, the sealant will be there and do this job. So what we'll have to do here is stand up so we can get to this easier. So we will stand up and flip this on one side. So what we're going to do is put 3 or 4 drops of blue Loctite in each hole. Now you don't have to do this. We do it on our units out of the factory because we don't know the application. You may use this once a month. You'll never probably loosen these bolts up. But if you use it 100 times a day, there's a good chance the vibration could loosen those bolts up. I won't say good chance, it could happen. So we go ahead and put a fail-safe in here to make sure that it doesn't happen. And about 4 drops of blue Loctite in the hole. 3, 4. And then we'll go ahead and run this down finger tight, flip it over and do the other side. This just makes sure that over time these bolts don't come loose. So just do a routine inspection of your device. If you see those bolts coming loose in your application, then go ahead and put some Loctite on there. If you don't see them coming loose, then there's no reason to put Loctite on there. But like I said, brand new out of the factory, you'll have Loctite already on there. You only will run into this if you disassemble it and feel the need to put Loctite on there yourself when you reassemble it. So we run these down tight and we will torque them to 75 inch-pounds. Not much, just snug. And I'll talk to you about what's special about that. So let me go ahead and snug these up. Go ahead and get a ratchet in on one side and make the job a little quicker. Alright, so that's snug. Alright, so I don't want to over tighten it, but I'm going to show you what I mean. If the perfect situation here is when you move one of these, the one above it doesn't move. You want to move one at a time. So if you come in here and hit it, you only move one. It's easy to know which one you hit. Okay, so now say if it's too loose and you come in here and hit it really hard, it bounces back. You don't want that. So you want it to be somewhat snug in there, but you want one to move at a time. Okay, so I have this pretty close to the 75 inch-pounds without even torquing it, but I'm going to go ahead and lay this back flat and torque both sides of it. And then that essentially completes your assembly process if you had a broken indicator on there. It's really the only reason you would have to disassemble this and reassemble it. So we will torque both sides to that 75 inch-pound mark. Make sure your hand is on the torque wrench at the right location, which is the grip. Boom, boom. Do a quick double check before that sets up. Make sure when you hit one, only one moves. It's not too loose, they're not too sloppy in here, which is what we want. All right. Last thing I want to talk about. We got some feedback from many of the users. They're like, okay, I get it, I like it loose. So, but when I do it too loose, I think I'm having problems. And what they're running into is, let's see if I have this really too loose. So the first one comes out, okay. So I have the inside one tighter than the top one. So let me loosen up this. I want that to move first, and I want these to move second. Alright, so that one moves really easily, okay? So I like that really loose. Let me run it up so it holds. Alright, so it's too loose right now. It's not even holding it in position. So let me tighten that up a little bit. Alright, there we go. Alright, so what happens if you have the top two too loose, you'll get the middle section to come down a little bit. And we don't want that. So right now it's too tight, so I'm not getting that. But you can get it to where if it's too loose, let me run this back down. I want to show you this real quick. So if it's too loose, I'm going to just loosen those up. That may be the right one. So we'll go ahead and extend it down. Alright, so what you don't want to happen is that this section comes out when you don't want it to. Okay, so if you get the top two too loose, this will come out before you really want it to. You want it to be a distinct amount of force to release it. You don't want the force of the first one to release the second one. So you want them both to be a little bit different. You want the top two to be a little tighter so it doesn't release. So if it doesn't release, you just have to extend it back up and kind of get it to pop back in place. Okay? And then run it back down. And if you're a little softer the second time, it won't come out. But the first time, if you pull it too hard, you may get it to come out. That just means you need to tighten the top two a little tighter, and that won't happen. Okay? So just look for that. That's the only thing that will throw your measurements off, if you have it to where the top two are a little bit too loose, and you get the second part releasing too soon. But essentially that's it, guys. Now you're an expert on the disassembly and assembly process of this. Hopefully you're not scared to do any type of repairs if you have to run into that. So feel free to call our 1-800 number if you have any questions or concerns. But now you're an expert on disassembling and assembling the unit. Good luck. And until next time, talk to you soon.